Jason, sprechen Sie Deutsch.
What the hell, Alex, do you have on the screen up there?
That's the Rosetta Stone.
The official Rosetta, not the program, but the Rosetta Stone, the official Rosetta Stone?
Yeah, it was the one that Napoleon broke.
Oh, that guy.
That's what you get for,
He did a lot. He let a lot of breaking.
That's what you get for rampaging around. You know, I love languages. I think they're so cool. And there's so much history involved in a language, especially the study of words, like etymology and where they came from. It can tell you a lot about people, the area, the culture, why they operate a certain way, you know, why a mountain is called a specific thing, right? Or how something has been carried through history. And MIT has absolutely crushed it with this system called CSAIL. I think that's what it's called. And it's a machine learning system that can actually translate and bring back to life these dead languages.
Think about that, guys.
Yeah.
So MIT's Computer Science and Artificial Intelligence Laboratory, CSAIL, can decipher a lost language.
Yeah, and all they need is a couple thousand words. So what they found is that there are a lot of vectors of relationships, so directional relationships, forward, backwards, up, down, whatever you want to call it, that would affect how this machine translates. So it looks at, one is the geography of a region. It looks at the history, like the cultural history. Then it looks at the etymology of how those words have moved over time from what our understanding was. And also the pronunciation, the consonants, the vowels, and the changing of like a P to a B. And so if it looks at these logical changes that they've become like essentially like anglicized over time, you can actually continue to drop back in certain languages, ones that have like an Aramaic base or ones that may have like a Greek or a Latin base, and be like, oh, now we understand how the development of these languages actually happened from point A, which was a lost dead language, to what we have now at point B that we're currently using. It's an albeit quite brilliant system. But in doing so, it's not the fact that you're bringing up this dead language back to life. It's all the history and context that comes with it. And so imagine an archaeologist goes to look at something and like at first the language is dead and there was no way to read it. But we have a system that can now translate it efficiently. And they can be like, oh, now I understand what's actually going on here. If I'm looking at cuneiform on a clay tablet, they used to press in like arrows or like almost look like greater than signs into a tablet. Like that was language. It's early written language. And so you can bring these things back to life and really understand what was going on. And maybe you could even understand concepts with the consciousness and how people operated. They thought in different patterns. Maybe something that we wouldn't recognize that has been lost that was truly special.
Yeah, it said the algorithm learns to embed language sounds into a multidimensional space where differences in pronunciation are reflected in the distance between corresponding vectors.
Yeah, so if you look at how the pronunciation, how it's actually being delivered for that word, and you look at the relationship historically in other languages that almost sit in that same sort of language family, it can then begin to decipher it and say, oh, I can see how these transitions logically happened from here to here and the cause and effect of the development of this language. And then from that, that's when you start to resurrect these things.
Yeah, and it said the proposed algorithm can assess the proximity between two languages. In fact, when tested on known languages, it can even accurately identify language families. The team applied their algorithm to Iberian, considering Basque, B-A-S-Q-U-E, as well as Slavic candidates from Romance, Germanic, Turkic, and Uralic families.
Right.
While Basque and Latin were closer to Iberian than other languages, they were still too different to be considered related.
Right. So we would have put them in that related category, but this algorithm with better knowingness, because we've programmed it to do so, said these are actually more closely related to these two rather than the both of them together. But I really think the real magic about this thing is having all that data input, having people. So consider a data packet on TARTLE where you're having someone read a sentence. Imagine if you had all of that raw data input for a natural language processing algorithm to go back. Okay, we have all the pronunciations, all the different variants, and all the specific subcultures from all these different geographies all across the globe. Let's pump it into this thing and then figure out how language has migrated over time, much like when you go on your Ancestry.com and when you do your like mouth swab to say, oh, my DNA's been here, here, and here. You can actually see the movement of that language.
Yes.
And that would frankly be more precise than actually trying to track DNA.
Yeah, MIT professor, I want to give shout outs to these because this is amazing. MIT professor Regina Barzilay, and then an MIT PhD student, they wrote the paper on this, Jaiming Lao. They're the ones that developed this decipherment algorithm. And here's what they want to say for their future work. Here's what they're working on. This is so awesome.
I love this.
I'll let you talk about this and we'll close out. In future work, the team hopes to expand their work beyond the act of connecting text to related words in a known language, an approach referred to as cognate-based decipherment. This paradigm assumes that such a known language exists, but the example of Iberian shows that this is not always the case. The team's new approach would involve identifying semantic meaning of the words, even if they don't know how to read them.
Okay, so if you don't know, so just be looking at these relationships.
Right.
We know what this word is telling us, even though we can't pronounce it.
Right.
So cognitively, we understand what they thought
Yes.
and what was trying to be projected through this writing.
Yeah, and I think what they're talking about is they want to have known historical evidence and be able to put that in there.
That's what I was saying.
And then have
Imagine
it
for
interpret.
an archaeologist,
Yes.
right? And so if you get all the bias of how an archaeologist might read
Yes.
hieroglyphics out of the way, now you're getting something special. And that's why I'm like, it's not, the language is important, but what's more important is understanding how people think, the balance of their thoughts, right? Maybe some cultures just in that language is a more unifying culture, or something that's, inherently more descriptive, something that does a better idea of actually vocalizing how someone thinks or feels, like German or Sanskrit.
Yeah, and shout out to MIT, bro. It's like every week we're pulling up articles from them.
They're crushing it.
They're crushing it, yeah.
So much creativity. That's
Yes.
all it is.
Yes.
It's scientific creativity there. They're not bogged down by, red tape and government stuff that you find over here at the labs.
And we would love to be able to, I mean, you're from that neck of the woods.
Yep.
We would love to be able to go up there and just hammer out. We would set it up. We could set it up there at at MIT and just hammer out podcast after podcast with professors.
What are you doing with data?
Yeah, exactly.
Sit right here at the table. Let's talk.
Yeah, these guys love to have them on a podcast.
Oh, most definitely.
We could just sit there for a week and just do like 100 podcasts. That would
I'd be so amped up to talk about data, like language, like the combination of those things.
Any of it. Yeah, artificial intelligence, machine learning. I mean, the list goes on and on.
Climate models, all that stuff.
Yeah, I'm reading another article from MIT, and I'm thinking about, and it's talking about machine learning, AI, and feminism.
Interesting.
Yeah, that's a whole concept because you don't think about that. Most tech companies are 90% white, these white privileged guys or whatever, and it's mostly male based.
Mm-hmm.
So to take these two women and they're making this perspective about, looking into this, that's just so creative to me.
I think, what's great?
It's only going to allow it to have more and more and more information.
Data, it just makes things more transparent and open.
Mm-hmm.
And then when you start to apply it properly, it starts just like bringing so much truth to light. And it's what we've needed for so long.
Mm-hmm.
It's now we're only just beginning to start to facilitate its use properly, effectively.
Yes.
Evolutively.
Evolutively, great word.
Yeah.